Ladies and gentlemen, we are gathered here today to say goodbye to the Jamstack, a revolutionary web development concept. It embraced simplicity, speed, security, scalability, and challenged traditional server-driven approaches. Static site generators coupled with JavaScript frameworks empower developers to create dynamic user experiences. Its vibrant community and open source spirit left a lasting impact. But now, it is dead. Or is it? For its initial few years, Jamstack was a radically successful idea, and it enabled a lot of new innovation in the space of front-end development. But over the last few years, the definition of Jamstack has become a little vague and confusing. Some people say server-side rendering is the opposite of Jamstack, while others stretch the definition of Jamstack to include server-side rendering. The concept and the community around Jamstack have kind of been on life support for a couple years now, and recently, Netlify decided to pull the plug on it. There's a lot of problems that surround the idea of Jamstack. So when I heard the extremely saddening news about its official death, I decided to take the obvious next logical step, which is to spend many hours trying to do a post-mortem analysis and dig deep into the rabbit hole of Jamstack. And I've emerged on the other side with some enlightenment. So in this video, we're going to do what we usually do on this channel, which is to dig into the architectural concept that powered the motivation behind Jamstack and see how it went from a concrete and opinionated way to build applications to this nebulous and vague conglomeration of frameworks and cloud providers. Now, one of the best ways to understand any sort of a software architecture concept or pattern is to think about a contrasting pattern, something that's on the opposite end of the spectrum, and then compare the characteristics of the two. So that's where we're going to start today. The pattern that sits in contrast to the idea of Jamstack is really the traditional monolithic single process application. So let's say we have a server here, let's call it the application server. And inside this server, we have our application. This application is usually a single process that's running in a container, or it could be a multi-threaded process, whatever. It could be written in really any programming language, PHP, Ruby, Node.js. But the idea is that this application is responsible for serving both our front end and handling our backend requests. So we're gonna have a user or the browser client that the user is using, which will make an HTTP request to our application. The application would then process the request, and then finally, it will send back an HTML response back to the browser, which is usually the entire new HTML document, which is akin to a full page reload, or it might send a partial HTML response, which will be replaced on the browser client. You can think of a WordPress application or a Ruby on Rails application or anything like that. They all follow this architecture or this pattern. So what are the benefits of having an application like this? Well, let's go through some pros and cons. First of all, it's very simple. There's nothing too complex going on here. We have been building applications like these for decades, basically. It's also very portable because this doesn't really have any constraints around how you deploy it, how you manage it. As long as you have a physical server or a container environment or a virtual machine, you can run this kind of an application anywhere. It's also very flexible because, once again, since there are no other constraints or opinions, you can do whatever you want. You can have multiple applications. You can break it up into microservices, or if that's something that you're into. But the point is that it's a very flexible design. But obviously it doesn't come without cons because every architecture is a trade-off. So the biggest one is that it's monolithic. It's a single process running inside a single server, which means it's going to be a little difficult to scale up or to scale out. Obviously, you can just keep expanding your server and keep buying better and better hardware, but you're going to hit limits very soon. So the most common thing that we do is replicate it or horizontally distribute it so that if you're getting a lot of traffic, you have multiple instances of your application to deal with all that traffic. But then that means that you somehow have to find a way to synchronize state between the two. You have to put a load balancer in front that can efficiently distribute the traffic between all your multiple replicas. Or you might also have just a completely external data store where every piece of application has to communicate with instead of trying to synchronize data between each other, which means you have to figure out how to scale your data and processing. Finally, the biggest problem with this kind of a system is that it's very high latency. Every HTTP request will have to go through a load balancer to figure out which application instance it's going to be processed by. Then it will get processed by that application, and then you will receive an HTML response back. So not only is there the latency of processing the request, there's also the latency of making the network request in the first place. What if your application is deployed to US East 1, but a user is trying to access it from Australia? That means that your network requests have to make multiple round trips halfway across the globe before your user can get any sort of a response back to their browser. Now, obviously, there's a lot of different ways to solve some of these problems, but they don't really achieve it all the way. It's still really difficult to build really nice and fast user experiences if you're using this kind of an architecture for your system. Now, around this time, there was this piece of technology that we were using for many purposes called the Content Delivery Network, or the CDN. CDNs are pretty widely used to serve media assets like images and videos, or even static files like JavaScript and CSS libraries, because they don't really change much. You can deploy these static files to CDNs, and they will be globally distributed and highly available without you ever having to think about the scalability. And you can have a lot of traffic that's trying to access these files, and the CDN automatically takes care of all of this. Now, around the 2014-2015 time period, there were people trying to ask the question of how do we use this technology of CDNs to make our front-end applications better, to serve better front-end experiences to our users. Now, because a CDN is just a static cache, really all you can do is to have some HTML files that are statically available on the CDN. Let's say the user is now trying to access your application. They will hit the CDN, and they will simply get back a cached HTML response from the CDN, something like this. Now, this really circumvents a lot of the issues that we had with the traditional server-rendered applications. So let's kind of go through the pros and cons for this style. First of all, because we are using the CDNs to deliver our application, we have basically infinite scalability because the CDNs are essentially infinitely scalable. We also have extremely low latency on the requests because not only are the HTML files statically cached and don't require additional processing by some sort of a web server or application server to be generated on demand, they're also globally distributed. So a user that's trying to access your application from Australia is not going to have to make a complete round trip to US East 1 to get their HTML response, because our front-end assets, or our HTML files, are going to be cached on a CDN server in Australia and most likely very close to their city, which means you can achieve very fast response times. This is really the goal that the Jamstack was trying to achieve from the very beginning. If we can convert our front-end to static HTML files that can be deployed on the edge, we can gain the benefits of the CDN through the infinite scalability and extremely low latency, which will result in really nice experiences for our user. But then the question becomes, how do we even achieve this? Because this doesn't really tell the whole story, right? Where does our processing happen? Where do the HTML files come from? Now, to achieve all of this, there are certain things that you can do. Around the time that the Jamstack was coined and people were trying to build sites like these, there weren't really a lot of ways to do this. Really, the only way to do this was to generate HTML files at some sort of a build time and then deploy those statically to the CDN. Now, this can be achieved using some sort of a static site generator like Hugo, Jekyll, 11t, Gatsby, anything like that. Now, the way that the static site generator would achieve this is that it would Now, the way that a static site generator would achieve this is that you would give it a set of templates or components. If you're using something like 11t or Jekyll, you would be using templates. Or if you're using a React-based framework like Gatsby, you would just have React components. But the main idea is that you would have a representation of your user interface, and you would give it some data that comes from some sort of an API or a database. The static site generator would then combine the two of them together and generate HTML files. These HTML files will then be deployed to your target CDNs, which is usually Cloudflare, but really can be any CDN provider. So your front end is really just the set of templates or components, how they accept data and convert to the final UI representation that your users are going to see. And your backend application now no longer has a UI. All it has to do is to serve data over an HTTP API or gRPC or really whatever. And this is what we call a headless backend. Because the backend doesn't have any UI of its own, the user only interacts with this backend through a set of APIs. Now, once you have your HTML files cached on the CDN, you can achieve really quick response times, once again, because it's statically deployed to CDNs. And if there's any additional data that's needed on the front end, on demand, you can have some JavaScript running along with your HTML that can make a request once again to your headless backend, and the backend would send the response back in a JSON format. Really, this is the kind of architecture that the Jamstack was originally about, because it helps you achieve the main goal, which is putting static HTML on the CDN so that you have almost infinite scalability and you have really low latency. So let's dig into this a little more and really go through the pros and cons of this type of an architecture. Another big benefit that this kind of a system provides you is decoupling between your front end and your back end. Now here you don't have a single monolithic process that's responsible for doing both the back end work and generating your front end UI. This has been cleanly separated into a set of components or templates, and a headless backend that's only responsible for providing data or providing some actions over an HTTP API, which means you can have two separate teams that work on two completely separate parts of your project, and the basis of the collaboration between them is the API layer, which is how the backend serves data to at build time or on demand. Now, whenever you have decoupling like this in your technology or in your software, you have the opportunity to outsource one of these things to someone else and really only own one of these things. So if your job, or if the job of your company, your software, is really to build the best front end possible, the best customer experience possible, and you don't really want to deal with how to build a backend, how to scale it up, how to build all of that infrastructure, because that's not where your business capability lies, you can simply use something like a backend as a service provider like Firebase or Supabase, or you can use a content management system like Sanity instead of building your own backend. Then you get to focus your entire time and your entire engineering effort into building the best front-end experience instead of having to worry about building the best backend experience, because that's not the goal of your business. You can also flip that around and make your business making the best backend as a service or making the best CMS systems possible, so that you can empower other developers and other teams to really focus on their front-end experience and never having to worry about the backend. But obviously this is just an option, you don't have to. You can also do the backend work on your own if you want to. Now, since this is an architectural pattern, we should take some time to really discover the characteristics of this architecture and what really makes it different from other architecture styles. Really, the primary thing that stands out in this architecture is that we have static UI that's deployed on the edge. We also have a headless backend that's completely decoupled from the front end, like we talked about. And all the data that's required to build our front end is primarily fetched at build time. The keyword here is primarily, not only. Obviously, you cannot predict all the data that your application or that the user will need when they're using your application. So you always will need some sort of client-side rendering and on-demand data fetching whenever you need some sort of dynamic UI. But really, to make the most of the CDN and the scalability and latency benefits, you have to fetch most of your data at build time and really only fall back to on-demand data fetching and client-side rendering when absolutely needed. Now, once again, we're talking about an architecture style which always comes with trade-offs, so we have to talk about some of its cons. Really, the biggest disadvantage of this kind of an architecture is having to redeploy. Now, these HTML files are deployed to the edge and they never really change. The only way to change them is to trigger a rebuild that will once again take your templates, get a new snapshot of the data from your backend, and generate new HTML files that will be deployed on the CDN that will replace the old HTML file. Which means whenever this data changes, you need to redeploy your entire site to make sure that the front end that's deployed on CDNs has those updates. Which means the best use case for an architecture like this would be some application that has infrequently changing data. This would be things like blogs or marketing sites, or really anything that's content heavy, that's impersonalized, and that's infrequently changing. Because it takes an entire redeploy to really update your application with new data, you have to make sure that your data is not changing too often, because then the cost of redeploying very frequently kind of overshadows the cost that you save by having a fast and efficient front end. But if your application has data that doesn't change too often, then this is really a great architecture that allows you to have front ends that are extremely responsive, and you basically never have to worry about scaling it because it's statically deployed on the edge. And initially when the term Jamstack was coined, initially when the term or the idea of Jamstack was popularized, this is the kind of system or the pattern that they were heavily promoting. Because after all, this really is the only way to achieve the initial outcome that we wanted to, right? Which is HTML on the edge. And this became very popular. A lot of people realized that actually a lot of their sites could really benefit from an architecture like this, and they started rewriting stuff to take full advantage of the edge and the idea of Jamstack. Now, if this is really such a structured and opinionated way to build sites, what happened to Jamstack that made it such a nebulous and cloudy concept? Well, after a couple years or a few years of the Jamstack being a really nice, peaceful architecture, there was a lambda-shaped wrench that was thrown into all of this. Let me explain. Now, just like how CDNs have existed for a while, but were never really used for this specific use case until Jamstack came around, lambdas have also existed since 2013 or 2014, something like that. But when lambdas were first released by AWS, it took a few years for people to really discover the use cases for lambdas, or what are some ways that we can actually use this technology and integrate it into our own application or development workflow and make our software better. Now, for a while, people that were building Jamstack websites treated Lambda as their backend, because why not? Lambdas provided a really nice sweet spot between building your own backend, between building and maintaining your own backend services, and between using a completely third-party service like Firebase. Because lambdas are essentially infinitely scalable on their own, you can write your entire application to run in a lambda, and you never have to worry about scaling it up or load balancing it or making sure the state is in sync, because those problems don't really exist in the lambda world. Suddenly, you can write all of your backend code that runs in a lambda instead of in a single machine or a single container, and you have basically infinite scalability out of the box, which means you have achieved a lot of the same benefits that a backend as a service provided, but you're also not logged into a specific provider or a specific programming language or a database technology, because you can really write your code in any programming language and deploy that on lambdas. So lambdas fit this use case very nicely. But there was one other thing that people were doing with lambdas that threw an even bigger wrench into this Jamstack architecture. Say hello to our good old friend, server-side rendering. Now, the last time we checked in with server-side rendering, we were building applications like these, which were single process applications that ran in a container or a virtual machine, and you had to figure out how to scale them with load balancers or external data stores or state synchronization. But now we have a way to do server-side rendering in a way that takes all of the infrastructure concerns away from us. So let's dig into this a bit. So once again, you have your browser or your user that's using a client browser. This will make a request to your application that's running in lambdas. The lambda would then process this request, and it would generate an HTML response that would be sent back to the client browser. It looks very similar to the original monolithic architectures, but now because the code is running in serverless functions, they can be automatically scaled up as much as you want, as long as you're using an external provider to manage your state or your data. Now, once again, let's talk a little bit about the pros and cons of building an application like this. Now, once again, because you're relying on cloud functions instead of containers or virtual machines, you have almost infinite scalability without ever having to think about it. You also no longer have redeployments, because all the front-end assets or your front-end HTML is generated on demand by the application. And finally, you have a little bit of familiarity because you can kind of take the same applications that you had in the original monolithic style, and you can deploy them to Lambdas without a lot of effort. Now, you do have to spend some time trying to optimize it to take full advantage of the serverless runtime, but it's a lot more familiar than Jamstack. So what's the catch? What are the cons? Well, the latency problems from the first architecture style come back to this, because you can only deploy Lambdas to a few regions or some select regions, which means if you've deployed your application once again to US East 1 and your user is trying to access us from Australia or some other faraway country, there will be a lot of round trips across the globe to make sure that they get back the response. But beyond just this high latency, you have a new problem called cold starts. Now, cold starts are not always a problem, but they're still a big issue whenever you're trying to do anything customer facing from serverless functions, because whenever a request is made, there might not be a container that's running your code, which means some extra time will be spent when the cloud provider is trying to spin up your code inside a container, and then it can start processing the request. But the point I'm trying to make is that Jamstack no longer had the sole claim to be the only architecture that gives you almost infinite scalability for your front ends without you having to invest a bunch into scaling your backends through Kubernetes or something like that. You get infinite scalability out of the box, very similar to how you got infinite scalability from Jamstack architectures. And you also don't need redeployments anymore. Now, the latency cost is still there, if not even worse than the first one because of the cold start issue. But now you can see that there's two ways to build application that both help you achieve infinite scalability. So if that's the primary goal that you're trying to achieve with your application, you now have a choice between static Jamstack style systems or putting your applications on Lambdas. So these are kind of the two ways that people were trying to use Lambdas or serverless functions to make their front ends better, either by doing server-side rendering or by using them for the backend in your Jamstack application. But once again, serverless functions is just a piece of technology. It doesn't prescribe how you build applications. It's just a piece of technology that you can use and incorporate in your existing architecture to solve certain problems. So a lot of the Jamstack community started asking this question of how do we take this technology of serverless functions to solve our own problems? Instead of looking at Lambdas as something that competes with this architecture, how about we try to integrate Lambdas into our own system to try to achieve the original outcome that we were trying to achieve, which is static HTML deployed on the edge? Because our goal is not only just scalability, it's also the extremely low latency which CDNs provide, which really elevate the user experience of any front-end application. So let's take another look at this Jamstack architecture and figure out how we can make it even better by using serverless functions. Well, we have our static HTML files here that come from our build process. What if they can also come from some Lambda functions? Since Lambda functions are basically compute on demand, how can we spin up a Lambda function that has our application or some part of our application, and it can generate an HTML file and deploy it to the edge whenever we need it to? This way, we don't have to worry about redeployments anymore. We can just change our HTML deployments on the fly without having to redeploy the entire site. Now, the first thing we need to figure out if we want to do this is when do we exactly trigger this Lambda? We know how to trigger it. We can just send an HTTP request or make a call through the AWS SDK or whatever cloud provider you're using. But when exactly do we do that? First thing we can do is to just have some sort of a timer or multiple timers. And we can define some rules like every minute or every hour or once every day, go and trigger this Lambda function. And then the Lambda function would do the same thing that your static site generator does, which is take your templates or components and take your data, combine them into the new UI or the new static HTML assets, and push them over to the CDNs. Great. Now we don't have to redeploy the entire thing. Now we can just define certain rules, and we can even do them for each individual page. We can define some pages to update once every day. We can define some pages to update once every week, or some pages to update once every hour. This gives us a lot of fine-grained control over how we want our static assets to update, instead of, once again, having to redeploy the entire thing. We can also have our backend send some sort of triggers or notifications to the lambdas, and when we can also have our backend send some sort of notifications or change events to the application that's running inside our lambdas, so that we can trigger some updates to our front-end assets when something in our backend has changed. So for example, if someone leaves a comment under your blog post, that can trigger a change notification, which will spin up our lambdas. It'll get a fresh list of comments for that blog post, generate an HTML file, and push that to the edge. So the next time someone visits your blog post, they will also see the new comment that's been placed there. But if our backend only gives us notification of what data has changed, how does the application know which pages to update? Now we also need our application to know which pages depend on what data, so that whenever there's a change in the data, the application knows that these are the specific pages that I need to regenerate and redeploy. You probably see where I'm going with this, but let's take a step back and talk about the pros and cons of this new architecture that we are trying to conjure up. Well, we're still deploying HTML or static HTML on the edge, so we have some of the same benefits that we had with the original Jamstack architecture, which is both infinite scalability and low latency. We also have decoupling between our front end and the back end, because your front end now runs either on build time or at runtime in a Lambda, and your backend is completely separate and only responsible for serving data. However, you actually have deployment flexibility, because you can combine this architecture with the server-side rendering on Lambda's architecture that we just talked about. What this means is that maybe you don't need this full decoupling between your front end and backend anymore if you don't want to. You can just get rid of the headless backend, which means now the front-end application doesn't need to request data from a separate backend service. It has its own state, and that means the on-demand data requests can go to the same application instead of to a different headless backend. Since you already have your own server-side logic, why do we even need to delegate the backend work to a separate service? So now you have the option to kind of do both. You can have a monolithic application that runs inside Lambdas, and along with having server-rendered interfaces, you can also cache those server-rendered HTML files on a CDN instead of serving directly to your user clients. But obviously you don't have to do that, and you can just go back to using a headless backend service. So what are some cons of this? Well, we don't have the big issue of redeployment anymore, because we can do fine-grained updates to our front-end assets on demand or over time, even after it's deployed. But there's still going to be issues if you're trying to display some personalized content. Because your front-end assets are statically cached, it's going to be the same assets that are served to all your users. Which means if you want to show different users different pages or different content, you'll have to rely a lot more on the on-demand data fetching, and you can't as well rely on the static caching of your front-end assets. The other thing that you might notice in this entire diagram is that it's a little bit complex. There's a lot of wiring up that is going on in this entire system. Not only do you have functions that generate HTML that are cached on the edge, you also have some timers that are running at different frequencies for different pages. You have notifications set up from your backend to your front-end application, which means your application also needs to know what pages need to be updated based on the data that's changed. And you're probably doing some sort of a combination of generating a bunch of HTML pages at build time and doing fine-grained updates on a timer or on data change. If you don't want to deal with the complexity of setting all of this up, you can use a framework like Next.js or Gatsby, and use a provider like Vercel or Netlify, which builds a lot of the primitives to do all of this inside the framework. But then you lose the portability that you had with all of the other systems. When you were just using a static site generator, you can use any static site generator and any CDN service and simply deploy all of your static assets to the CDN, and that's it. But now, because you have a lot more orchestration of cloud services going on, you have to kind of buy into certain frameworks or certain providers that do all of this wiring up for you, which means it's a little more difficult to go from one framework to another as easily. And the final problem, which you might recognize as one of the two biggest problems in computer science, is cache invalidation. Because now you're treating your static assets not as things that you deploy, but as things that you cache. They're no longer snapshots of your data that were taken at build time. They're now caches of your data that need to be invalidated either when the data changes or on a certain set of timer, which really is kind of a headache for a lot of applications. But if this is a good trade-off for you, if you can deal with the cache invalidation issues in your application, or your cache invalidation issues are really simple, and you don't have a lot of personalized content, and you're okay with buying into Next.js, then this is a great architecture, and it will help you build really scalable and really low latency applications. Now, this architecture really is the result of people trying to incorporate the technology of serverless functions or on-demand compute into the existing Jamstack architecture. Now, obviously, the million-dollar question now is this Jamstack? What do you think? Is this Jamstack? Let me know in the comments down below. I'm obviously going to talk about it more, but maybe at this point you can scroll down to the comments, and of course, while you're on the way there, hit the subscribe button as well, and leave your own thoughts. Is this too different from the original Jamstack architecture, or does this still count as Jamstack? I'm going to take a snack break while you do that. Pop-Tarts are amazing. This is not a sponsored ad. All right, let's talk about what is Jamstack. Now, I think there's really two ways to answer this question. They're both from different perspectives, but they kind of point to the same thing. It's like two sides of a coin. The first one, I like to call it the outcome perspective. This really asks the question, what are we trying to achieve? Now, I've talked about this a bunch of times throughout this video, that the thing that we're trying to achieve is static HTML assets that are deployed on the edge or on CDNs. Now, obviously, a lot of people, especially the ones that were there from the beginning, that were really involved in the creation, the popularization, and the community of Jamstack, a lot of them align with this outcome perspective. They say that the goal of the Jamstack was to build front-end applications that can be cached on the edge so that we can get the extremely low latency and infinite scalability advantages that the CDNs provide us. From this perspective, this is obviously Jamstack, but this is also Jamstack because this also achieves infinite scalability and low latency, and it does that by helping us cache static HTML assets on the edge. It's just a different mechanism behind it, but the outcome is still the same. One of my great friends, Anthony Campolo, or better known as AJC Web Dev, runs a podcast called JavaScript Jam, and also a newsletter called JavaScript Jam, and also another podcast called Full Stack Jamstack. Basically, he has been really invested into the Jamstack community and the Jamstack idea for a few years now. In his latest newsletter edition, he gave his entire take on the death of Jamstack, and his thoughts align really well to this outcome perspective, which is that the entire idea of the Jamstack was to build better frontends by leveraging the CDNs, and in that sense, Jamstack never really died. It just evolved over time to incorporate newer technologies and innovations in the cloud space. I highly recommend you subscribe to JavaScript Jam, not just to read Anthony's thoughts, but also to get amazing web dev news delivered to your inbox every week. This is not a sponsored ad either. Anthony also puts a lot of quotes from a lot of other people, including the one given by the CEO of Netlify, who was one of the original people to heavily popularize and evangelize the idea of Jamstack. And for great reason, because Jamstack is legitimately a great way to build better front-end experiences, especially when compared to a traditional, completely server-rendered applications. Now that's the first perspective, and according to this perspective, Jamstack never really died. It just evolved to a point where a lot of people, a lot of frameworks, and a lot of companies started investing into the idea of Jamstack so much that it's basically become a mainstream way to build modern web applications. Companies like Shopify and Wix have invested quite heavily into this idea of Jamstack, or putting static HTML on the edge, and the existence of a self-contained Jamstack community or conference is kind of no longer needed because it has won. Everyone's doing it now. That's the perspective that a lot of people have taken towards this, the death of Jamstack. But the other perspective, is the rules perspective. The rules perspective really asks the question, how do we build applications? And this how is actually more than just vague ideas of architecture patterns. It also includes what are the specific tools and practices that I need to follow to be considered as Jamstack. Now, if you take this rules perspective, you'll see that there's kind of a big difference between this and this. The existence of Lambda functions that generate HTML on the fly and cache them on CDNs really shakes things up a bit. You no longer primarily rely on a static site generator or on atomic deployments, because now your application that runs on serverless functions is actually doing the bulk of your work, and a lot of your focus shifts away from redeployments to fine-grained cache validation. And beyond just that, the rules of building an application like this are drastically different. You suddenly have to think a lot more about frameworks like Next.js and Gatsby, or providers like Netlify and Vercel, instead of just building a Jekyll site and sticking it on GitHub pages, which was a completely valid way to build a Jamstack site because it nicely follows this architecture. If you define Jamstack not as the outcome that we're trying to achieve, but as a set of rules and technologies that are used to build great applications, suddenly this new architecture style, it's not really Jamstack anymore, unless you also stretch the definition and stretch all the rules to include these new technologies and frameworks. This is the perspective that my colleague Jeff Escalante has taken and has been very vocal about for a couple of years now. His argument is that Jamstack has been used by Netlify as a marketing tool. If Netlify can tell people that Jamstack is one of the best ways to build applications, and we have offerings for developers to build Jamstack sites, it's a great marketing tool because Netlify is not the only one that believes in Jamstack. Other people do as well. And the point that Jeff really tries to drive home is that for Netlify, the priority was always marketing and not the community. And because the marketing around their cloud products always took higher precedence, they gave up on having these strict rules of how to build Jamstack sites and expanded them to include a lot of these new architecture patterns like incremental site revalidation or stale while revalidate, and a lot of these terms that you'll hear throw around whenever it comes to caching stuff on the edge. Now, I don't necessarily disagree with either of these perspectives. I think both of them are completely right and valid from their own points of view. To the people who took the outcome perspective, I completely agree with that Jamstack is not really dead. It's just become mainstream to the point where we no longer need really this self-contained community of Jamstack. It's not the underdog anymore, it's the champion. But to people who take the rules perspective and say that Netlify has been really opinionated about this, they've been shifting the rules to serve their own marketing priorities first, honestly, I don't see a reason to disagree with them. There is actually a lot of proof that Netlify used Jamstack as a marketing term first and as community later. If you've been around in the Jamstack space for the last 2 or 3 years, you might have heard that Netlify has pushed this idea of the composable web for a long time. They've even redefined Jamstack to include composability for a while now. Now, I don't know too much about what this composability means, but my best understanding, the argument that Netlify makes, is that you might not have just one headless backend that serves data to your front ends. You might have more than one. You might have a content management systems for blogs and comments. You might have a CRM system. You might have a different product catalog. You might use a different customer support service. Basically, if you're working in a large enterprise, you would have a lot of these different services. And then when you try to build a front-end application, this application has to know how to talk to all of these services instead of just one of them, which really increases the complexity of building front ends. So the idea of composability is that there will be some sort of a unifying layer that sits between your front end and all these different heterogeneous backend systems that you have. And it will offer a single API layer, either through GraphQL or REST APIs or really whatever. But that will be a single API interface that your front end can now talk to instead of having to figure out how to talk to all of these different services and maintain all of the different adapters. That job is now done by this middleware that gives you the composability. Now, We went through both of these styles of Jamstack, and we never really ran into this issue of composing from various backends. That's not really something that helps you put HTML on the edge, which was once again the outcome that we were trying to achieve with Jamstack. So if Netlify has included this composability in their definition of Jamstack, clearly they don't themselves take this outcomes perspective, because composability has nothing to do with the outcome of putting static HTML on the edge. So Netlify has definitely been a little loose with how you build Jamstack sites and what does Jamstack mean. And in doing that, they kind of gave up the original idea or the outcome that really kicked off this idea of Jamstack and formed this entire community around it. So those are my thoughts on this, on the death of Jamstack. And now it's your turn. Do you take the outcomes perspective, and do you think that Jamstack didn't die, it won, and now it's no longer needed as a self-contained community or idea or movement? Or do you take more of the rules perspective and think that Jamstack was kind of tainted by the addition of these new technologies and these new rules and Netlify's new offerings, and that meant that it had to be killed? Let me know in the comments down below, and make sure you hit that like and subscribe button.